When people hear the word Anthropocene, they often imagine its impact being more global, melting ice caps, climate change, or mass extinction. But what if evidence of the Anthropocene could be found much closer to home? Here in Connecticut, the Long Island Sound offers a local example of how human activity is reshaping natural systems. Through pollution, synthetic materials, and ecological stress, the Sound reflects many of the environmental changes associated with the Anthropocene. So how do microplastics and ecosystem disruption make the Long Island Sound a marker of the Anthropocene? I believe that the Long Island Sound is a local marker of the Anthropocene because it contains both physical traces of human activity, like microplastics and ecological signs of disruption caused by pollution and development. The Anthropocene is often described as a new geological era shaped by human influence. Unlike past eras marked by volcanoes or asteroid impacts, this one is marked by cities, emissions, plastics, altered rivers, and damaged ecosystems. One of the clearest modern markers is plastic. This graph shows how global plastic production rapidly accelerated after the mid-20th century. If you focus on the top part of the screen, around the same time many scientists identified the beginning of the Anthropocene. As plastic use expanded worldwide, so did plastic waste and eventually microplastics in the environment. Plastic did not naturally exist before humans created it. Today it's found almost everywhere: oceans, rivers, beaches, soils, and even in the atmosphere. Over time, larger plastic items break down into microplastics, which are tiny plastic fragments less than 5 millimeters in size. These particles can come from bottles, packaging, clothing fibers, tire dust, and industrial waste. Plastic pollution is not only a distant ocean problem. In Connecticut, researchers and local workers have documented and removed trash from rivers like the Mill River in New Haven, showing how inland waterways can carry waste towards larger coastal systems. This goes to show that what begins as everyday waste does not simply disappear. It breaks down into microscopic fragments that spread through water, soil, and air, leaving traces across the planet. This widespread contamination is so significant that researchers now view plastics as a lasting geological marker. Plastic is accumulating in ocean sediments worldwide, creating a new layer in Earth's history that has never existed before. Due to the high production of plastic, microplastics are now becoming part of the planet's permanent geological marker. As you can see in this image, rainwater does not simply disappear, it becomes runoff. It enters streams or moves underground, and along the way, it can transport pollution towards the Long Island Sound. The Long Island Sound receives runoff from cities, roads, rivers, and suburban development across Connecticut and New York. That means plastic waste and synthetic particles from inland communities can eventually move into coastal waters. Researchers have also found that microplastics can be carried by wind, allowing them to separate and spread globally, even into Arctic snowfields. Once there, microplastics can remain suspended in water, settle into sediment, or be consumed by marine organisms such as fish, shellfish, and plankton. This matters because sediment layers often preserve materials over time. If future geologists examine modern coastal deposits, plastics could become part of the lasting physical record humans leave behind. And that is exactly what makes plastics an Anthropocene marker. While my artwork may not belong in a museum, this sketch does help illustrate how everyday plastic waste moves throughout the environment for the average person. It often begins with someone throwing away something like a plastic bottle or synthetic material used and created on land, and then rainwater then carries that waste into storms, drains, which then flows into rivers and streams. Those waterways eventually lead into estuaries like the Long Island Sound. And once plastic enters sediment, over time, those buried plastics may remain in the layers of the earth, creating evidence of human activity for the future. And that is what makes plastics more than pollution. They become a geological signature of the Anthropocene. But the Long Island Sound reflects more than plastic pollution. It also shows how human activity disrupts ecosystems. An ecosystem depends on the balance between organisms, habitats, water quality, and nutrient cycles. Human development can disturb that balance through excess warming waters, habitat loss, and pollution. Nutrient pollution in the Long Island Sound has historically contributed to low oxygen zones, also called hypoxia, where marine life struggles to survive. To better understand what is being lost, it is helpful to compare these stress conditions with the clean waters that healthy aquatic ecosystems naturally depend on and expect. As you can see in this image, it is reflecting a healthy ecosystem that is clean and with oxygen-rich water. This image is actually an untitled painting from the University of Connecticut's William Benton Museum of Art, which shows a typical northern New England bedrock stream with clear, oxygen-rich water, as I mentioned, low nutrient content, and continuous flow from fractured rock aquifers, conditions that support healthy aquatic ecosystems. Yet not all connected waterways remain in this natural state. As water moves through developed landscapes, human activity can alter its chemistry, nutrient balance, and ecological health downstream. Together, these changes show that the Long Island Sound records both the physical traces of human activity through microplastics and the biological consequences of human disturbance through ecosystem distribution. This type of environmental stress is not unique to Connecticut. This infographic maps more than 500 coastal areas worldwide that have experienced human-caused hypoxia, showing that low oxygen stress in marine ecosystems is now a global issue. Estuaries and coastal waters are particularly vulnerable to excess nutrients, which have led to the widespread growth of hypoxia around the world. This demonstrates that the Anthropocene is not only about materials humans leave behind, it is also about the biological systems humans transform, which are being altered faster than many species can adapt to. And while these changes may seem global in scale, their effects are deeply local. The Long Island Sound shows how worldwide environmental pressures are experienced in the everyday landscapes and communities in Connecticut. The Long Island Sound is especially important because it connects environmental processes to the everyday life in Connecticut. It supports fisheries, tourism, biodiversity, and coastal communities, yet also collects evidence of how modern-day society consumes resources and produces waste. It shows that global environmental change is not only happening in the distant oceans or in climate changes, it is happening in local waters closer to home. In conclusion, Long Island Sound can be understood as a marker of the Anthropocene because it contains both physical traces of human activity, like microplastics, and ecological signs of human distribution, such as pollution, stress, and habitat change. Its waters remind us that the Anthropocene is not a distant future. It is a present reality, and in Connecticut, we can see it in the Long Island Sound. Thank you.